We know that if we have a triangle, its circumcircle and its circumcenter, then this equals r. And so in this isosceles triangle, we can construct this segment, which is the altitude, median, and angle bisector at the same time. And now the question is, what is its length? Well, we see a right-angled triangle here with hypotenuse r, and this angle is gamma. Then this side must be r times the cosine of gamma, similarly to how this side was r times sine of gamma. By symmetry of argument, we know that if we take the circumcenter and drop perpendiculars to the other two sides of the triangle, then their lengths would be, respectively, this would be r times the cosine of alpha, and this would be r times the cosine of beta, like this and like this. But what happens when angle gamma is obtuse? Then what's the distance between the center of the circle and the midpoint of this side? As we know, when gamma is obtuse, this angle here that corresponds to this arc is twice as much as gamma, so 2 times gamma, and then this angle equals 180 minus gamma, and this angle equals gamma minus 90. Now since this is r, and this is a right-angled triangle with angle 180 minus gamma here, then this side we know is r times sine of 180 minus gamma, and similarly, this side here is r times cosine of 180 minus gamma. Now, what is cosine of 180 minus gamma in terms of cosine of gamma? Well, let's take a look at the unit circle here. The angle gamma corresponds to this point on the circle. I've chosen it such that gamma is obtuse, so starting from here, we go to 90, and here we go to gamma. Therefore, this small angle here must be 180 minus gamma, and so I've constructed this point on the circle such that this ray corresponds to an angle 180 minus gamma. Then, this line and this line are symmetric with respect to the x-axis and with respect to the y-axis. We know that in this case, cosine of gamma would correspond to the horizontal projection of this point on the x-axis. So it would be this distance taken with a negative sign, and the cosine of 180 minus gamma would be the projection of this point onto this x-axis, so it would be this distance taken with a positive sign. And so, because of the symmetry, this distance equals this distance, but their signs are opposite to one another. Therefore, cosine of gamma, which is this length, is minus cosine of 180 minus gamma, which is this length. In other words, cosine of 180 minus gamma equals minus cosine of gamma. So we can replace this expression here for this length, and so we get that this distance is minus r times cosine of gamma. But how can a distance be negative? Well, this angle gamma is obtuse, and obtuse angles have negative cosines. So the negative sign from the cosine of gamma would cancel out with the negative sign here, and would give a positive sign for the length of this segment. The lengths of the altitudes from the circumcenter of the triangle to the other two sides, so this altitude and this altitude, this would be r times cosine of alpha, and this would be r times of cosine of beta. And that would be because this angle here is beta and this angle here is alpha. So from this right-angled triangle, we get that this is r cosine of beta, and from this right-angled triangle, we get that this is r cosine of alpha. Here's the optional problem. We have a circle. This point is its center, and this is a chord in the circle. So we've drawn the altitude from the center of the circle to the midpoint of the chord, and then this line is tangent to the circle at this point. This line here is the altitude from this point to this line, and so this line is perpendicular to this. And also, this line passes through this tangency point and is perpendicular to this line. And then this line and this line intersect here at this point. We have to prove that this blue segment equals this blue segment here. And here's the solution. Let's construct a triangle here, such that this point is randomly chosen on this arc, and let's call this angle gamma. Then, from the alternate segments theorem, we know that this angle here is also gamma because this is a tangent line to the circle. And then, because this is a 90 degrees angle, this angle is 90 minus gamma, and because of the sum of the angles in this triangle, this angle is gamma. From the law of sines, we know that this side here is 2 times r sine of gamma. Therefore, each of these two equal segments equals r times sine of gamma. We also know that the distance between the midpoint of the side and the circumcenter of the triangle is r times cosine of gamma. Now we need to prove that this length is also r times cosine of gamma. But now take a look at this triangle. It's a right-angled triangle with right angle here, and this side is r times sine of gamma, and this angle is gamma. Therefore, this side equals this side times the cosine of gamma divided by sine of gamma. Now the sine of gamma is going to cancel out, which means that this segment has length r times cosine of gamma, and this segment has length r times cosine of gamma, and so they must be equal.